Hey, my name is Dallin Carter, and this is my ME305 final project, which is a piano pedal actuator. And the problem that it solves is there is a guy that I know back in my home church congregation that he loves to play the piano, but he recently just fell and got paralyzed, and he's paraplegic, so he can't use his legs. And so he can play the piano with his fingers just fine, but he can't use the sustain pedal anymore, which is a really important part of playing the piano. And so what this does is essentially it uses this force sensor that he'll bite on to move this motor, which converts the rotary motion into linear motion through a cam and a follower. And so as this cam spins, it'll push the pedal down for him. So here is a demonstration of the device actually working. So I'm going to put my finger underneath the follower right here, which is going to act as the piano pedal. And so as I was mentioning before, here is the force sensor that I'm going to bite on. So this acts as the feedback control of my device. And so what happens is when I bite on this, it'll send a signal to the Arduino and let it know how hard I bit down, and correspondingly it'll move the motor to a specific angle depending on what bite force I give it. So if I give it a really strong bite force, it'll move to 180 degrees. If I move to anything a little bit less than that, then it'll move to anything in between 0 and 180 degrees. And if I release my bite, then it will move back to 0. So here's the demonstration. The device also has an LCD screen and a user input, which I have this rotary encoder here. And so as you spin this, you can adjust the RPM of the motor if you want it to go faster for any reason, or if you think it's going too fast, you can make it slower. So here I'll start at the default setting. And then if I move it to, let's say, 210 RPM, it moves a lot quicker. All right, and so here is a video of the device actually working. So now I'm going to play the piano, and I have to keep my foot on top of it so it doesn't topple itself over. It looks kind of funky, but here goes nothing. So now I'll just kind of do a walk around of my setup here. So here is an integrated DC servo motor that operates on 36 volts. Here is the cam, which is made out of cast aluminum. Here is the follower, which has a bearing to mate well with that cam. Here is the LCD screen and the rotary encoder. Here is the buck converter, which steps down that 36 volts, which goes into the motor, which steps that down to 12 volts to control the Arduino inside. And on the back, we have the power converter, which converts the 110 AC from the wall, and it converts that into the 36 that this motor needs. Here's the device now with the back and the power converter taken off so we can see what's inside. And as you can see, there is an Arduino right there with everything hooked up to it. And I've also got a proto board with all of the 5 volt hooked up right there, and all of the ground hooked up there, just so I didn't run out of the 5 volt or ground pins on the Arduino. And also just to make sure that I didn't miss anything when explaining the feedback loop, basically what happens is the Arduino goes to the bite sensor and it says, hey, has anything bitten you yet? And it says, no. And so then it goes back and then it asks it again, repetitively. And once it says yes, then it says, okay, by how much have you been bitten? Like what's the value? And then it will give it a value, and correspondingly, the Arduino will then say, hey motor, according to the value that we have received, move to that angle. And so then the motor will move to that angle, and then the Arduino will keep asking the feedback sensor, or this force sensor, if it has changed, and if it has, then it will update that angle correspondingly. And while this is happening as well, the Arduino will say, hey, encoder, have you been turned? And it will say yes or no. If it says yes, then it will update, or the Arduino will tell the motor to then spin faster or slower depending on how much it was moved. So that is my project in a nutshell, and thank you so much for watching.